Today, we're going to crack open a GCSE chemistry exam question on electrolysis. And I mean, we're not just going to find the answers, we're going to build the perfect response, step by step, showing you exactly how to lock in every single one of those marks.
Okay, so here's our game plan. We'll start by decoding the experiment itself. Then we'll break down how to answer the questions about both the positive and negative electrodes. After that, we'll switch things up with a new solution and then wrap it all up with a playbook of key strategies to help you ace these things.
Right. First things first, we've got to set the scene. Before you even think about putting pen to paper, it is absolutely crucial to be a bit of a detective and look at all the information the question gives you. Trust me, the biggest clues are always hiding in plain sight. So this is what the exam paper shows us. It's a pretty classic YouTube apparatus, right? You've got your DC power supply, it's connected to 2 electrodes, and those electrodes are just sitting in this green solution.
Now, this is where it gets really interesting. The question gives us some extra detail. It tells us the solution is green because it contains blue copper ions and yellow chromate ions. Now, that is not just some fun fact they've thrown in. It is a massive clue that's going to directly help us answer the first part of the question.
Let's go ahead and tackle those first 2 questions. And here's a pro tip. We're going to construct our answers using wording pulled directly from the official mark scheme. This is all about learning to think like an examiner.
All right, so question 04.1. It asks for a 2-mark explanation for why the color changed at the positive electrode. The question already told us the solution around this electrode turned yellow, so why did that happen? To bag both of those marks, you need 2 distinct points. First up, you have to identify the correct ion and say where it goes. The mark scheme wants to see CrO4 2- or chromate ions move to the positive electrode. That's 1 mark, right there. For the second mark, you have to explain the basic science behind it. Because opposite charges attract. Simple, direct, and exactly what they're looking for. Next up, we've got a nice, straightforward 1-mark question. It tells us that oxygen gas is produced from hydroxide ions, and it just asks, where do these hydroxide ions come from? The one and only correct answer they want here is simply water. You have to remember, this is an aqueous solution, which means the copper chromate is dissolved in water. And the water itself can split up just a little bit into hydrogen ions, H+, and hydroxide ions, OH-. It's those hydroxide ions that are doing the reacting at the positive electrode. Okay, let's get into the 3-mark question now. We're going to switch our focus to the other side of that YouTube and explain exactly what's going on at the negative electrode. Question 04.4 asks us to describe how the solid forms at the negative electrode. That keyword, describe, is our big clue. It means we need to lay out a process. And for 3 marks, you can bet we're going to need 3 key details. So to get all 3 marks, you just lay out the process step by step. First, the positively charged Cu2+ ions move to the negative electrode. Second, when they get there, each ion gains 2 electrons, and the number 2 is important. And third, this whole process, called reduction, turns the copper ions into neutral copper atoms, and that's the solid you see forming on the electrode. And check this out. This is probably my favorite exam tip. If you're feeling confident, you can skip that whole written description. The mark scheme explicitly says that just writing the correct balanced half equation, Cu2+, 2E- turns Cu, gets you all 3 marks in one go. It is the most efficient and complete way to answer the question. Okay, for the final part of this question, they change the scenario. This is a classic move to test if you can apply the basic rules of electrolysis to a totally different solution. So the copper chromate is gone. Now we're electrolyzing potassium iodide solution. All we need to do is name the product at the negative electrode and the product at the positive electrode. The mark scheme confirms that the answers are hydrogen at the negative electrode and iodine at the positive electrode. But why? Well, at the negative electrode, you've got K+ ions and H+ ions from the water. Since potassium is more reactive than hydrogen, the hydrogen is produced as a gas. At the positive electrode, you have I- ions and OH- ions. In this case, it's just easier to pull an electron from the iodide ion, so iodine is formed. All right, let's wrap all this up and build our perfect score playbook. We can take everything we've just learned and turn it into a solid strategy for any electrolysis question they throw at you. Here it is, your playbook for success. Number 1, always identify all the ions in the solution, and don't you dare forget the ones from water. 2, Never forget the golden rule: opposites attract. 3. Be super explicit about whether ions are losing or gaining electrons. 4. Learn those key half equations we saw, what a great shortcut they can be. And finally, number 5. You've just got to know the rules for predicting which products will form based on reactivity.
So you see, by breaking down not just the answer, but the structure of the answer from the mark scheme's point of view, you're basically learning to think like an examiner. You know exactly what they're looking for, and with that kind of insight, you're well on your way to absolutely mastering this topic.